Let's look at estimating the instantaneous rate of change. That would be the slope of the tangent line. So here I have this graph f of t equals 4t squared minus 4. I have that graph to the side. T minus 1 is that point on the graph right where it crosses the x axis. It's an x-intercept. And I'm trying to find the slope of the line that touches right there at x equals 1, that tangent line. So to find that, I'm going to take the slope of the secant line from t equals 1 to a point that's really, really close to 1. So we're going to find a bunch of average rate of changes here. And I'm just going to set up those intervals to begin with. So perhaps I'm looking from 1 to 1.1. Let's look at 1 to 1.01. And I'm going to find the slope between these points. Let's say I have 1 and 1.001. And then we'll do one more. We might find that we need to do more than this, but this is a start. I'm getting really, really close to 1 to try to find a line that touches at 1, or at least really close to it. The average rate of change is slope, so I'm going to create a table here so I can see things a little bit better. And I'm going to type in 1.1, 1.01, 1.001, these inputs so I can see what's going on with the outputs. 1.0001. Okay. And I'm going to switch to tablet mode. I would encourage you to pause the video and try to find the slope of these secant lines, these average rate of changes between these inputs here. So you're thinking rise over run. So go ahead and pause the video and give that a try. Let's find some average rate of changes. Average rate of change. I have the change in my x values on the bottom here. So my x values are 1.1 and 1, my inputs. And on the top, I'm going to have the corresponding y values. At 1, the y value is 0. That actually makes these calculations a lot nicer. And at 1.1, it's 0.84. When I do the math here, I end up getting an average rate of change of 8.4. Let's find the next average rate of change and see if there's a pattern to these. I'm looking at the change in my x values on the bottom, 1.01 and 1. Of the corresponding y values from the table, 0.0804 and 0. And when I do this, I get an average rate of change of 8.04. Next average rate of change. I'm looking at the change in my x values on the bottom, 1.001 minus 1. On the top there, I have 0.008004 minus 0. This is giving me 8.004 for that average rate of change. And for these last points, I have 0.00080004. On the bottom, I'm looking at the change in my x values, and this gives me 8.0004. What I'm noticing is that this is getting closer and closer to 8.00000. I'm picking up more zeros each time I do this. So the average rate of change goes to 8. So the instantaneous velocity at this t equals 1 value looks like it's getting really, really close to that number 8. When we learn derivatives in the power rule, we'll see that the derivative at t equals 1 is 8, which supports this claim. That's another quick example. Let's check out some more together.